Welcome to Code of India. Today our topic is calorimetry. It is a follow-up of the previous lecture, heat and transfer. As it has been told to you all, the temperature is the reference of heat. And it was calorie which used to measure, then it transferred treated as a heat with a unit of joules. We have discussed all these things earlier video. Now what is the calorimetry? Metry is well defined as a matrix of the heat, measurement thing, calorie measurement, calorimetry. If we consider the two objects of different temperature are in common surface contact, if the element 1 is TA temperature, is having the temperature TA, and element B having the temperature TB, and if TA is greater than TB, then what will happen? If TA is greater than TB, then heat transfer took place from the A object to the B object till it reaches to equilibrium condition of the temperature of the both of the element. So you understand the specific heat and the mass of that A component, A element, and we will do that. So suppose that T is the temperature of the both body at equilibrium condition when the both body temperature is equalized. At that time the difference of temperature of the A material is what? TA minus T, and total heat how much? It is heat into mass, and that total heat should be equal to the B material with temperature difference T minus TB, and AC heat is what? TB and the mass, and that should be equated. So heat transfer time is the simple that how much time it will take come in an equilibrium condition with both of element in accordance with the temperature. It is clear to you? So, what is latent heat? Latent heat, that is what? It is a heat required to convert a solid into liquid or vapor, or liquid to vapor. We know the matter have three types: solid, liquid, vapor, gas. So this is a state. When it is changing from one state to another state, and to change that, what are the heat is required? That heat is called latent heat. Clear? So, a large amount of heat has to be supplied to water to 100 degrees centigrade to turn into steam. Then water, liquid to steam, 100 degrees centigrade, and that's equal to, if you multiply it, that will come the 539 calorie per gram as opposed to more 100 kilocal per gram of the 100 centigrade. This does not change the RMS speed of the molecule. it goes into potential energy. When before boiling, before 100 degrees centigrade, it was just increasing the potential energy. After boiling, it will expose up. So this latent heat must of course be included in the calorimetric type of bookkeeping. What is evaporation? You generally know the surface area increase, the rate of evaporation is more. To cool anything, hot thing, you keep in the pot of more surface area. Then area is the factor, surface area is the factor. So when you bring the water in a closed container, it is not full of water of that two portion, remaining is a air portion, then equilibrium took place. The liquid vapor equilibrium is established. The partial vapor pressure depending upon the temperature. As you know the formula. And there is a latent heat associated with the evaporation. Evaporation means what? Liquid to convert to gas at the time that the latent heat is required. There is a property of that matter. So, more energy to escape from water to at 20 degrees centigrade. Then 100 is 539 kilogram per cal per gram, and for water to evaporate at 20 degrees centigrade more energy required, that 585. The cooler water is denser and exert a slightly more powerful attraction. As the vapor formed, liquid fuel is losing its fastest molecules. This is how sorting works. So what is thermodynamics first law? You know the internal energy of any heat object. That you can set a control volume. This room is more heated as compared to outside. So this wall arc we can consider the layer of the obstruction of the heat transfer. Okay, because the wall is made of different material. So this energy can be changed into two different ways. As you know, in our earlier classes, that what is called work done in gas, that is the compression and expansion. When you compress any air charge from higher volume to lower volume, work done. When the gas expands from lower volume to higher volume, that is also work done. So what are the internal energy that when heat transfer took place, the internal energy will give the two results. There is a work or heat work done on it, or heat work on the system. That I told you, that the compression expansion and heat, total heat can flow into system or flow out of the system. This room, the wall, is depending upon the temperature outside, inside, whether the heat from this room will go outside or outside will come to inside. that this room can be treated as a system of the control volume. That wall is the parameter, material property is the parameter. The first law says that total energy conservations, what are the heat having in the room, that is minus work done, is the change in internal energy. That is what? Change in internal energy. The change of internal energy equal to heat in, what are the heat it was, and the work done. The work done is minus, then it become plus, and what is plus is become minus. Plus minus is an analogy. The heat is coming from outside to this room, or heat is going out from this room to outside, where wall is treated as a control volume. So, the state of an ideal gas. Suppose we have an n mole of the ideal gas in the equilibrium in a piston. Okay. The quantity of gas inside the piston and head of that cylinder. The state of the gas can be defined by giving the variable P and V that I told you earlier. The gas state is point in the PV curve of the value of P and V. If heat is exchanged or work done, heat exchange means what? Volume decrease or increase, or temperature decrease or increase according to the direction of the volume increase or decrease. Then what is? That is a state variable trace of path, that PV curve, how the thing will go. This curve name is isothermal. This curve name is isothermal. This is isothermal curve. The PV, what are the value of PV put on test lab, then the value will automatically join the line with the value. It look like this isothermal curve. That as PV equal to constant. So, if you think when the compression took place, then what will happen? Is a closed volume. Cylinder is a closed volume. Compression took place. There is no relation outside inside due to the cooling system outside wall of the engine. That isothermal is two types: the endothermic and exothermic. That is not in your syllabus. You will learn in higher. Anyway, then how to measure? I told you earlier the measurement of work, that is a change in volume. If we consider a small change in volume, that is a dV, okay, and we'll all add the value of the, suppose VA was the volume after final volume is VB, and if you add the all, then what we'll get? You will get the total work done. Okay? It is an integration that you know in the calculus. Integral means what? Adding the value of PV, okay, where PV is the small incremental of that change in volume. Piston is pushing. I am taking a small change in per unit change in volume. That is dV. And that value we are putting from this lower and upper limit. That value put and add it all. That is called integration. Means integrate. Okay. And P dV we know the P equal to dV equal to what? That equal to P dV equal to nRT divided by V. And that will become what? We will solve it this. if this integration break it, that is become the log of V by A. Okay, so you know this is log of V by A. If we learn everything, what is log, integration, that you have to learn after a few days. So this is the thing that different part of state A and B, as this is here. So this is, I told you, this is car name is isothermal. Okay, and this is isobaric. Here is a constant pressure. And this is what? Isovolumetric, as constant volume. Isobaric as constant pressure. No, your pressure is constant at this line. Volume is increasing or decreasing at constant pressure, and the pressure is increasing. This is pressure, this is volume. Okay, and pressure is increasing, decreasing at constant volume. And this curve is following the property of P into V equal to constant. So the heat, the work done heat may be observed by the system or heat thrown out to outside of the system. If observe it, that is endothermic, and if throw it out from the system, that is exothermic. It's clear? So it's solved.